college algebra, this video is for you. We are going to start chapter 7 here. This video will just be part of the first section, 7-1. But let me just paint a broad picture here first. Chapter 7 is about solving systems of equations and systems of inequalities. So let's begin with just what is a system of equations. Well, a system of equations is just a set of two or more equations. Okay, that's what a system of equations is, a set of two or more equations. And in this section, every system you see will just involve two equations. Okay, so let's just give an example here of a system of equations. I'm going to write the equation y equals x plus 3, and then the equation y equals 4 minus x. Okay, so I have one equation, two equations, and together those comprise a system of equations. Now, notice there are two unknowns in each equation, so I can't really solve this equation individually. I can't find a value that y has to be or a value that x has to be. There are a lot of different combinations of x and y that will make this equation a true statement. Likewise with the second equation. But together, okay, this system will have a solution. Okay, so now, there will be some systems that don't have a solution, but this system should have one solution. Now, this is a system of equations represented algebraically. I'm going to represent that same system of equations graphically. We all know we can graph an equation in two variables on a coordinate plane. So that first equation, that is a line with a y-intercept of 3 and a slope of 1. So it should look something like that. The second equation is also a line. This time the slope is -1 and the y-intercept is 4. So it would look something like this. Remember, the slope's -1, so it's going to go down from left to right and crosses the y-axis at 4. All right. There are an infinite number of points on this line. There are an infinite number of points on this line. But there's only one point that's on both of those lines. And of course, it comes at the intersection point. And that point right there, that is what's called the solution to the system. Okay, remember, this is a system represented algebraically. This is the same system represented graphically. And that system, no matter how it's represented, has a solution. I can't really tell where they cross, okay, but it'll have, that point will have an x and a y coordinate. We'll just have to figure out what they are. So that's what a solution to a system means graphically. Now, I mentioned, I can't really tell where they cross. If I graphed it on a calculator or on Desmos, I probably could tell exactly where they cross. But I can't just graph it freehand like this. But that's not really what this section is about. What this section is about is, how do I find that point where the two lines intersect without having to resort to a graph, okay? So we're going to learn a couple of algebraic methods to figure out the solution to a system like this without having to graph it. Okay, and the first method, and the one that this video will focus on, is called the substitution method. So this is going to be called the substitution. This is one of the methods out of section 7-1. All right, so I am going to write a system of equations up here. I'm going to use one that's a little different from the one I had up there earlier. Okay, so x minus 9y is 12. Okay, so we have a system there, two equations, each one has two unknowns. I could represent that graphically and try to figure out where the two lines intersect. I might have good luck. I might be able to figure it out, but more than likely, I probably wouldn't. So what we're going to do is we're going to use an algebraic method called the substitution method. Now, the first step in the substitution method is this. I have to solve one of these two equations for one of the two variables in it. So that leaves me 4 choices. Okay, think about it. I can solve the first equation for x, or I can solve the first equation for y, or I can solve the second equation for x, or I could solve the second equation for y. Now, oftentimes there's not really one choice that's better than any of the others. But if you look at this for a minute, it looks like the easiest road to take here is to solve this second equation for x, simply because I can do it in one step. Now, there's no right or wrong choice here, but I think we'll have to do less work if we solve this second equation here for x. So that's what I'm going to do. And of course, all I really have to do here is add 9y to each side. So I get x equals 12 plus 9y. Okay, so I did step one. I solved one of the equations for one of the variables. Specifically, I solved the second equation, the x variable. All right, now, if you look at this, this says that x is equal to this expression right here. Circling that expression. So in this system, the value of x always has to be exactly equivalent to the expression 12 plus 9y. Well, the second step in this method, and this is why it's called the substitution method, is I am going to substitute this expression into whichever equation I didn't use in step one, which would be the top equation. I'm going to substitute this expression in place of x, because if you look at it, x is exactly equivalent to 12 plus 9y. So I'm going to write this top equation again. So the first thing in that equation is a 2. Now, the next thing is x. This is 2 times x, but I'm not going to write 2 times x. I'm going to write 2 times this expression, which is equivalent to x. And then the rest of the equation, plus 3y equals 3. That stays the same as it was before. Now, what is so beautiful about that? Well, look at the equation that I have now. This equation only has one variable in it, and that is y. Now, that y occurs 2 times, but that's okay. It's still just one variable. Okay. So I can, since this equation only has one variable in it, I can solve it for y. Okay. Thomas, go take care of the washer right now. Now. Sorry, the washing machine got unbalanced. Thomas has to fix it. Okay, so I'm going to solve this equation for y. Notice I distributed the 2 through the parentheses. Okay. Next, I'm going to combine like terms. I have a y term here and a y term here. So I combine the 18y and the 3y to make 21y. Let's continue. It looks like to get y by itself, I'll want to subtract the 24 from both sides. So I get 21y equals 3 minus 24 is negative 21. Okay. Now, to get y by itself, I just have to divide by 21 on both sides, and we can see that y is going to be equal to negative 21 divided by 21 is negative 1. Okay, so I know that these two lines cross at some point where y is negative 1. But to find the exact point where they cross, I need the x value as well. Well, here's what I can do. I know that y has to be negative 1. So I can take that value, negative 1, and I can substitute it back into either one of those original 2 equations. And then I'll be able to solve that equation, whichever equation I choose for x. It doesn't matter. You can put the negative 1 in for y there. You can put the negative 1 in for y there. You should get the same answer. So I'm going to raise this business here. And I'm going to take that value, y equals negative 1. Now, I'll put it maybe in that second equation there. So x minus 9 times negative 1 equals 12. I replaced the y with its value, negative 1. And now, let's see, so negative times a negative is plus 9 equals 12. And now, if I subtract 9 from each side, I get x equals 3. So now I know the x coordinate of the solution to this system, as well as, remember, I know the y coordinate as well. And what I do is I write that solution to the system as an ordered pair, where x is 3 and y is negative 1. If I were to graph those two lines, that's the point where they would cross. That's called the solution to the system. Now, that's the first method that you're going to want to be able to do in section 7-1. I'll post a video a little bit later about the second method. Okay? Thanks for watching. We'll talk to you later.